couple seconds. And I think we are live.
Woohoo. Okay, so welcome you all for the qualifying exam from Renato. And following, so thank you, Mauricio, and thank you, Andre, for being here. And I really appreciate your taking your time to read the text and see the presentation. And the qualifying exam is an important step on our PhD program. And on this step, the student has to show some maturity that shows that he's able to complete his PhD soon. So the idea is that Renato is going to have a short presentation, around 30 minutes to 40 minutes. And then we can have a session when we can ask questions and comments and whatever. And finally, at the end, we have a deliberation when we will seal the destiny of Renato regarding this qualifying exam. Do you have any doubts, Andre? I think you never participated before, but Mauricio is aware because he already passed it on our system. He knows how it works.
Yeah.
So
No, it should be good.
Perfect. Renato, whenever you're ready.
Okay. Well, thank you again, Andre and Mauricio, for coming, and for Gold for being also here. So today I will present you a little bit about my research proposal, which is a metrics-oriented architectural model to characterize the complexity on machine learning-enabled systems. A little bit of a mouthy title, but let's take and see what it is. So my main supervisor is Alfredo, who is here with us, and my co-supervisor here in the Netherlands is Professor Damian Tambure, who also gave some valuable insights with everything that we were doing. So let me click here to start. Yeah. So our goal with this project is to use a metrics to identify where complexity emerges in the software architecture of machine learning enabled systems. And in order to achieve this goal, we created a couple research questions that could guide the research that we want to make. So the first research question is related for us to finding out what are the measurable dimensions of complexity in the architecture of a machine learning enabled system. So the first focus is to understand if we want to measure things, what is related to measurements in respect of these systems. Then our second research question is about how can complexity metrics be operationalized over the architecture of machine learning enabled systems. So once we find some of those metrics, then the next step is that we need to learn how we can actually measure them over the systems. And finally, our third research question is related to how can complexity metrics be used to aid the development, operation, and evolution of real-world machine learning-enabled systems. And this third research question is quite open because it would be a very, to say the least, a very daring goal to try to solve every problem related to complexity. So we broke this third research question in two parts. So the first sub-research question related to research question 3 is how can complexity metrics be used to choose between different architecture proposals for a machine learning enabled system. So this sub-research question is specifically related to the idea of evolution of systems, and that when people discuss architecture, usually that's the moment when they are taking these key decisions to evolve the system. And the second sub-research question is related to how can metrics be used to identify refactoring opportunities of a machine learning enabled system. And in this scenario, identifying refactoring opportunities is mostly related to maintenance and also containing the spread of complexity in a system that already exists. So I think one important thing to highlight in both of those super research questions is that we are mostly focusing here on, since you already have a system, how you can improve its situation or avoid it to get worse due to complexity. So we are not necessarily trying to make something that will enable us to foresee how complexity will emerge or even contain complexity. Because let's say our initial idea is to be a little bit more humble and just provide something that can help real developers to maintain, to evolve their existing systems in a more objective way. So since I'm talking so much about machine learning enabled systems, the first thing that I want to talk here is about a reference architecture for machine learning enabled systems. And most of these literature review I made was based on a previous work made by my co-supervisor here, Professor Demian, and also a couple of colleagues here at the Jheronimus Academy of Data Science. And this idea of a reference architecture is essentially us trying to aggregate what are all the possible pieces that we could find in such a system. Moreover, given that we are trying to measure what are those systems, we need to define what are the scope of them. So what is the components, what are the parts that we actually need to look when we are talking about those different systems. So here I have a little bit of a glossary of the images that I will show. And in this legend, I have some little squares that represent services or application. These stacked squares are pipelines, which means things that execute on or on schedule in general. We have the cylinders that typically represent storage. And then this diagram kind of tries to summarize both the execution and the data flow related to the applications. In the case of the execution flow, either actions that are being started by a service to trigger another service or the continuation of this specific actions. And also on the data flow, either request response or read and write operations, depending on where those guys are connecting. All those systems here that are part of a machine learning system, or these components, are actually divided in subsystems. And every component, I put some labels that were particularly useful during my textual explanation of everything related to this diagram, but can be useful also for us to discuss here today. So just in this little square below, I have a little example of how those things will be used, but now I will address the whole diagram. So here is at least 50% of this reference architecture related to the machine learning enabled systems. And to go through it, I will try to go subsystem by subsystem just to highlight some key parts that we will have to pay attention in the future. So the first and main part that we should get concerned related to a machine learning system is the data acquisition. And data acquisition can happen in multiple ways. In particular here, I listed some of those ways that are very commonly used. This includes from physical sensors like IoT devices or any kind of hardware that is capturing data for us. We have data crawlers or whatever technology that scraps the web or any documents that make sense to extract raw data. We have data collection applications, which actually mean applications built specifically to acquire data for a certain project. And we also have the option, and it's very common in machine learning projects, that you could buy somehow data from third-party services and integrate that way. Finally, one of the most interesting uses that we can give to a machine learning system is when we are creating actually a system that feedbacks it on itself. So the data that it produces from the interaction with its users ends up giving signals that you can use to improve the system, which is what we call intelligent systems. So all those different sources here that are illustrated in orange, they ended up feeding for us a raw data store that can be made on very different ways. And when we have problems that are related to supervised learning, that's when usually we also need a way to label our data. And labeling, depending on the problem, can be a big issue, a big source of complexity, because some labels are very hard to acquire. So in general, some supervised learning problems can be more harder than unsupervised learning that just don't require all these pieces. When we have data, the first step that is related to the life cycle of one of those systems is related to development. And usually the development properly of all the modeling or all the intelligent piece inside our system is made by data scientists, usually using some technologies like notebooks. And I mean Jupyter notebooks or any related alternatives that we have nowadays. Usually when people develop these, when data scientists develop these first projects, they are focusing on an experimental path. And in this experimental life cycle that they are doing, the notebooks are particularly useful to quickly iterate on different versions. However, when we go for a more production version in which we are focusing on maintenance, then it's when nowadays it's almost, I would say, widely understood in the literature that we should abandon the notebooks, which are bad for maintainability, and go back to code editors, to IDEs, or whichever technology used for traditional development. Because then you need to redo the pieces of your system and actually think about redoing them in a more traditional software engineering way. And then this leads me to these two latter components. One of them is what we call the continuous training subsystem. And the continuous training subsystem is actually what encompasses this production version of what the data scientist did. So if the data scientist, usually they will have three major steps on whatever solution they are doing to train a model. One of them related to data processing, another to feature engineering, and a third related to training. And those three things can become three separate independent systems depending on the circumstances, just because we have a multitude of roles of people doing those different pieces, and also those patterns, which are these data storage related here. If we are using some sort of traditional data store for raw data processing, if we are using a feature store, or even a model repository, which are nowadays considered machine learning design patterns, though all those things kind of incentivize that we do those three pieces as three different subsystems, each one with a specialized stack and done by specialists on these certain types of technology. This is kind of the heart of our system. But in order for us to achieve continuous delivery and actually be able to create a factory of models, we need other types of pipeline that do the more traditional infrastructure side of things. So for the parts of our system that are very traditional, we always can have our CI/CD pipelines as we were used to do in typical software systems. But for the intelligent components, for those components that have the machine learning inside them, usually we have an extension of this concept, which is the continuous delivery for machine learning pipeline that in essence kind of brings together for us two things. Besides the code that can trigger us to regenerate a new version of the system, it also has a dependency with the model, and the model plays a role in that sense to also be composed by this pipeline to generate your last piece to serve your predictions. And this leads us to the two final subsystems that we have. One of them is the servers, which are the components that will integrate with whichever consumer application that we have, and can come in many flavors depending on the particular use case that your system have. You can have from traditional APIs to batch pipelines up to having streaming services, which in my opinion would be the most complicated ones. And in certain scenarios, they are justifiable depending on your constraints. When we finally implement these servers, and these servers can also have this prediction store, which is in essence, in its simplest form, a cache that you can put over in front of your servers to avoid repeating requests and redoing work unnecessarily. But it can also be considered, in more sophisticated case, a whole track of everything that can happen related to one of those servers. When we have all those server components, we finally can try to keep telemetry of the system and go to monitoring, where in monitoring, we have two options. Either we go in a more automated way with a monitoring service that will calculate for us whatever observability things that are important, or we can have a governance application that is something that gives the control to humans back to decide if a version of the model is actually having a problem, it's becoming incorrect, what we call the model drifts. So when we have these two scenarios, the monitoring service and the governance application, they can be associated even to make a semi-automated workflow to decide when we want to retrain or even review your proper modeling that you did. And of course, one last thing is that sometimes people even support A/B testing on this, which means do everything that I told about, but more than once. Because in those scenarios, what actually happens is that we have in parallel more than one model being maintained to test multiple versions. So this is kind of the overall scenario, the landscape of what can happen when we have a machine learning enabled system. But to make things a little bit more concrete, I also brought during my thesis an example that I will discuss now. So one project that I have been working since the beginning of my PhD is the SPIRA system. And the SPIRA system was an interdisciplinary project created with the idea of detecting respiratory insufficiency via voice. It's something that came up during the pandemic. And in the pandemic, we actually got all this bunch of specialists and asked ourselves, so can we use machine learning somehow to help identify that someone is breathless, in essence? And in that early days of the pandemic, when people didn't have proper biological tests to assert that someone had COVID, it was really useful. Nowadays, the goals of the project even surpassed these initial ideas, because nowadays the problem of respiratory insufficiency can actually happen by multiple problems beyond COVID, with people with asthma, with people with cardiac insufficiency. And if possible, it would be even more interesting if we could identify what is causing a respiratory insufficiency. So if those different patterns, they are identifiable depending on the sickness, if it makes something different in your voice. So this is kind of the overview of what the SPIRA system tries to achieve. But then in the beginning of my PhD, I helped to architect what would be a machine learning enabled system to achieve this goal. And this is the picture of, in the same or following the same notation that I presented early, of all these different components related to the machine learning enabled system. So in this scenario, we have a couple parts and the same major subsystems that I presented earlier. So SPIRA has a data collection subsystem in which we are trying to join, or we actually built a whole application to collect data, and we had to explore many different alternatives to understand how we could properly create an application that would not put bias into our data. And also, it's the idea of integrating with hospital APIs or hospital data sources in general, because that's the only way how we can know that someone with potentially respiratory insufficiency, what they actually had, and then label our data to solve it as a supervised learning problem. So this data acquisition is a great example of a system that has just one of the multiple different sources that we can have. And in general, it's even desirable that for most systems, they don't have that many complications, that many data sources related to them. So the second part related to SPIRA is the continuous training. And since the data sources in SPIRA are also not that super complicated, we actually can do it just with a feature engineering pipeline and a training pipeline. We don't need a properly separated data pipeline beforehand, even more when we consider that a whole data pipeline like that is actually more useful when you have multiple of those machine learning enabled systems living together. Then we have a component related to server, and serving in our scenario, we went through the path of doing a streaming prediction server. And specifically, this decision was based on the idea that the kind of model that we were gonna run inside SPIRA, which was a neural network, can be quite heavy. And so the prediction time could take a while. It would depend on specialized hardware. And the requests that we would receive could come in bursts, just because the client application that we were receiving inside hospitals, inside a hospital, the connectivity is, the mobile connectivity is bad. So if someone was using a cell phone, they would have a really hard time to upload each audio. The data collectors would have a hard time uploading each audio individually. So we need to attempt, if possible, to receive multiple requests, queue them, and then answer them as quick as possible, but knowing that our model is in the more heavier side. Then, among those last components that we have for SPIRA, we will need something for monitoring, because we also need to determine if drift is going to happen. But considering the problem, the odds for us to have drift are a little bit lower, because in the case of SPIRA, I mean, the problem of people with respiratory insufficiency doesn't change with time, as would be with other systems that have problems more time dependent. We have a development part, because we know that it will be important in the future to iterate in the first modeling that was done in SPIRA, because then it will be possible to try to improve and create from the first version of the model, which was just a classifier, you have or you don't respiratory insufficiency, go towards something that could, for example, make multi-label classification. So you have respiratory insufficiency, and it looks like this is asthma. So just to make this kind of improvements, this kind of evolutions, we need to support the development part and with their related continuous delivery pipelines, so we can upload these new versions and make them available in the whole system. So SPIRA is an interesting representation of all these generic reference architecture I presented previously. And just on another note, one of the things that SPIRA was really useful is that it actually was built throughout many projects that I helped supervise throughout my PhD. So many students that myself, together with Alfredo, we had into different capstone projects from bachelor students, and they were iteratively, piece by piece, building this system into multiple projects. So given that I talked about the machine learning enabled systems, we know the context of them, we talked about an example of these, then finally we can go and discuss how I intend to answer the research questions I proposed earlier. And then this leads me to my research methodology. So my proposal of a research methodology is made of 3 phases. And in these 3 phases, each one will focus on a specific research question. Each phase is also divided into different steps, or at least 2 steps, and those steps will be executed consecutively. So for phase 1, focused on the first research question, the first step is related to making a systematic literature review, which is with the goal to analyze the existing literature of software systems complexity and try to understand how this relates with machine learning engineering in general. In particular, we see that there will be challenges related to that because our machine learning enabled system doesn't have only the code dependency. It depends on code, it depends on data, and it depends on modeling. The literature on software metrics is very rich, but it's not as rich with those other areas, and they will influence a lot what we imagine will be relevant to describe the complexity of such systems. So when we get and finally do a compilation like this, the next step for us will be try to assess all the metrics that we compiled and categorize them. We can imagine that some of those things just in principle will happen. For example, we will have code, data, and model related metrics. So this is a very natural division for our ontology, but we will need to think a little bit more about different other kinds of applications. And there are very well documented processes through which we can kind of build this ontology and get somewhere. In phase 2, related, so when we have all those metrics in hands and we understand how complexity is being measured, then next step for us will be designing this so-called metrics-oriented architectural model that I was discussing about. So the idea of this model starts first with an exploratory case study. And in this exploratory case study, the idea is that I would get a very well-known system to try to get rid of the problem of understanding how the system works. But considering that this is a system that is representative of what we have related to machine learning enabled systems, then we can use that to come up with or select which metrics should be part of this model. That's the reason why I discussed so much about SPIRA, because our proposal is that using SPIRA as this example project, and then afterwards we can wrap up and do at least this initial version of our model. Then when we come up with an initial version, we know that SPIRA is representative, but it doesn't contain everything that the reference architecture talks about. So the next step would be to do a confirmatory case study. And if possible, in that scenario, I want to go to the industry and possibly using some partners that we have here in the Jheronimus Academy of Data Science, we can come up with ideas to validate this model. So it's very likely that in this next step, we will iterate and end up with many different versions or consecutive versions of this model. If something that we came up with during SPIRA does not stays like that for other real-world systems. Then when we kind of saturate this modeling step, or at least we are happy enough with a first official version of this model, then we can go for the third phase, which is to assess the applicability and then look for, well, we created this model, we want this model to be useful for real machine learning engineers, for real developers all around. So in the first step, the idea is to make something more close to developers and select a couple more experienced machine learning engineers to make a controlled experiment. And in this controlled experiment, essentially try to do a two-step process in which we would analyze some example scenarios. In those example scenarios, we would first not have the metrics and then have the metrics in hands. And then we can try to assess and understand how those different machine learning engineers, they can use this new tool and actually try to validate that this new tool is being helpful for them, or even how helpful or in which way they can be helpful for people. When we do a controlled experiment, and knowing that doing a controlled experiment like that will require just a few people, because those are very, let's say, work-intensive research to do. And also it's hard to find people that have this availability for these longer students. Then the next step for us would be to go for a survey research. And in a survey research, we could get the first understandings of how those things are helping our first set of developers and try to achieve more or reach the general community. And by reaching the general community, we can actually see if more people agree with the initial impressions we had during the controlled experiment. In essence, with that, we would have more certainty related to the usefulness of our model and then answer the third research question. Now, it's important to highlight that each one of those phases will give us an interesting deliverable. So in the first phase, the idea is that we will have this state of the art about metrics regarding machine learning enabled systems. For the second phase, we will have an industry and academic-based case study on complexity metrics for the ML-enabled systems. And in the third part, we would apply a mixed method approach to assess the impact of complexity in development tasks for machine learning-enabled systems. And we believe that all those results that we get as we execute the research are, in the future, publishable results. So it's as much as we, or it's our goal to get these intermediate results and get them for peer reviewing by our community. The only thing that is always good to discuss about the methodology is some threats to validity, because as any research, we can foresee that there are limitations. And when we discuss threats to validity, we actually can have 4 types of them. We have the constructive validity, which is, can my study measure what it proposed to measure? We have the internal validity, which is, can the study produce the results I want to report? Third, we have the external validity, which is, can the study be generalized to other contexts? So can we get those results and actually claim that it's like that in the real world? And finally, we have conclusion threats to validity related to, well, so can our study be replicated by other researchers? Since we have here a very experimental software engineering-based research approach. And for each step here, we can foresee where those different threats may appear. So for the step for the first step of the systematic literature review, we know that our dependency with data from knowledge bases is an internal threat. Then when we go and build an ontology, we have a construct threat related, because this building a ontology is a process that depends on the researcher, and we can peer review with other people, but there are limitations related to that. Then we have, for the second phase, a tough job of choosing which case studies we are doing. We are trying to justify as much as possible our inclusion-exclusion criteria for them, but the case studies that we choose will influence the research, and this is an external threat. And then we have something related to conclusion, which is the selection of metrics. After all, the metrics we will select will depend on our choice as researchers. For phase 3, we have another construct threat related that we are intended to build examples of different stuff. So we need to actually think very carefully about which examples we will provide to do this research and be valid. And of course, we also have an external threat related to sampling, because we are limited to whoever we can achieve, whoever we can reach during those research. As I said, we are trying to do some stuff to avoid those problems. We will try to use established publication databases during the systematic literature review. We'll follow the best guidelines from the literature related to build ontologies and also build the SLR, so we can avoid all of those construct threats. We'll try to make very clear inclusion and exclusion criteria for the case studies, which will be based on this idea of the reference architecture and having all those components that we are saying. We want to have, by design, this idea of having an exploratory and a confirmatory case study is to avoid us to fall in a trap related to our conclusions. So by having multiple case studies, the goal is that we can minimize during the creation of this metrics-oriented architecture model, any conclusions that would be not very generalizable. And finally, for the third phase, we have this issue again of the constructed examples. We'll have to take a lot of care when we build those things, and to try to sample the population of practitioners, we will try to use as much of our network as possible to reach all those machine learning engineers. And that's where I think both supervisors I have in my project shine, because they are very well connected in with the overall community. Networking is it's one of their greatest abilities. So that said, that's my plan to execute this research. And the last thing I should show for you is just this is my essentially idea of when I want and how long I expect it will take each of the pieces. But this is my presentation. So thanks for placing it to me.
Thank you very much, Renato. So now we're going to the second phase of the qualifying exam. So I would like to, I don't know, usually use the far away criteria to choose who is going to talk. And I think Andre is the farthest away because he's not in Netherlands where Renato is, and he's kind of far from our group. So Andre, could you please ask your question, comments?
Sure. And although I'd like to point out, technically, Alfredo, you're probably furthest away in terms of miles at the moment. So, but yes, I'm gonna ask that there's kind of one question upon reading that has been on my mind that I would like to focus on. But I'm gonna ask it in different ways. And so the first question I'm gonna ask is, what's the biggest risk to your study? And it's a very indirect way of asking the real question that I want to ask, but I want to hear your thoughts about it.
Um, I think there are two, I would say two very big risks come to my mind. First is the execution, of course, because I think that I have some conscience that the result I'm trying to achieve is a very, I'm looking for the word for that. It's, I'm trying to achieve something that is hard to achieve, in summary.
Okay.
Because complexity is a very old problem in computer sciences. So I don't think that it's possible at all to solve completely this problem. So I think the research I'm proposing here is like first steps to better understand this. Yet all this research methodology is a complex research methodology, and with the time I have up to until the end of my PhD, I'll have to work hard to do every step. But of course, between many things that I said here, I have big dependency on projects to make these things actually work. Most of those ideas that are here rely on my previous experience working as a machine learning engineer, but also the real world projects, if we have access to them, will make a better result. And I'm not sure if or which projects we'll have access to by the end of the research. So I think this is kind of my summary, Andrea. It's a mix of executing the thing, but also the things I depend to execute it.
Yeah, in a way, I agree with the size. There's a lot of components, and we could talk about that later. I agree with the notion of having access to industrial systems, but I'm going to ask my question in a different way. If any of the steps along the way failed, which one would you not want to have fail?
Which one? Oh, yeah, the last one, because
The
it's
last
related for
one.
me.
Okay. All right.
Yeah, the last one, I mean, in the sense of like, for me, I would imagine phase 3 in principle. My rationale behind it, it's because for me, when I try to research about software engineering, and the reason why phase 3 is there is that I want something that can impact people. So for me, it would be frustrating if I can do a nice work, but it's not very useful for people. So I think that's what comes to my mind. Of course, step 3 is not realizable if step 2 doesn't work at all. So I know that if I can't come up with a good model in step 2, I will not even reach this step. But this concerns me a little bit less, just because, at least in my mind, we can make a limited model, I believe. It will not be thorough, it will not be complete, cover everything, but we can propose a first step. And with this first step in mind, we can see how useful they are for people. But then again, we reach the point, or I'm not entirely sure if how far we go with this step 2, how useful they will be during step 3.
Okay. So I'm good. If folks don't mind, I'm going to continue the questioning for just a little bit. So I agree that we want step 3, right? That's the ideal goal. We have practical impact. But let's make a really practical question, which is you want your PhD.
Yeah.
Right? If step 3 failed, would you still be able to write a dissertation?
I think so.
Okay. If step 2 failed, would you still be able to write a dissertation?
It would be a little bit harder, I think.
But doable. Yeah.
Yeah. Yes.
If step 1 failed, would you be able to write a PhD?
Yeah, step 1, I think it would be the minimal in a sense. At least if I'm talking about this subject about metrics and other stuff.
So that's sort of where I want to go, right, with my set of questions. I think you're very, very dependent on what everybody else has done in the metrics field for your research. Because your statement is, I'm just going to look what everybody else has done, and I want to apply that to these machine learning systems.
Yes.
So now getting to the real question that I've been wanting to ask, which is, what makes you think that these existing metrics are even applicable?
Yeah, so
Because you set up your dissertation with like, ooh, machine learning systems, they're very different. They have code and they have data and they have models. They're very, very different. And I'm like, all right, I'm ready to see what kind of metrics, Renato is going to propose. And then I read, I'm going to do a big literature survey. I'm going to look at all the existing metrics, and then I'm going to build a model out of those. And I went, you just said your systems are different. What makes you think that any of the existing metrics is useful or applicable or any of the other
yeah.
things?
So I think that's something that I didn't focus to report, but what I have been discussing with both my supervisors for a while is which metrics we could include in this study. In my strategy, or at least what I intend for executing the SLR, would go both to reach different publications related, as was said, to the traditional software parts, and then I can think in multiple layers. So some of the research that I found interesting that I could include things go even from the very raw metrics, like the most basic, which is a cyclomatic complexity, can gives us some idea of complexity in the lowest level. But the software engineering community, they also go for metrics in the other layers, like the module layer, the class layer, the function layer, etc. So in the end of the day, everything that is still implemented in the machine learning enabled systems reflects into code. And I think many of those metrics, when applied for different parts of those systems, can be a proxy of complexity in other places. For example, I can look at the data processing stage, and in the data processing stage, I would guess that depending on the number of parameters I have, I could, for example, foresee how many different data sources you have. How many different data sources you have is something that I can imagine that is a metric related to data, does not express necessarily in software, influences a lot the complexity of the system, reflects into the software, but it could be a metric independent. And that's even why I think afterwards, if I executed the ontology part, why we could have redundancy between those metrics. Because different things that are measurable, when we measure them, will express related concepts, or express related problems, even if they are proxies of them. For data specifically, I found some literature related to big data in which people are describing what happens on traditional, very data-dependent, data-intensive systems. So related to things like the velocity, variety, volume, all those things data engineering-wise that people have. Where I think it's the hardest time is to actually quantify some things that I have intuitively that are components related to models, but I am not sure how much people proposed actual measurable metrics for those things. For example, I have the intuition that if I choose to make a machine learning enabled system that uses a decision tree, this is much simpler than using a neural network. But it's these intuitions, it's where I think it's the biggest challenge to actually become something measurable. And for models specifically, yet I haven't found many people discussing those stuff. I think the last component that we have, that I have been discussing both with Alfredo and with Damian, was related to more of a component graph approach to look at those metrics. So, if you describe your system as a graph, try to put their dependencies, like I myself drawed here, some of the data flow, some of the workflow. How much could we assert on different dependencies that we have based on that? And I think this is a more also well-explored approach in the literature. So yeah, this is kind of the overview of why I think it would be doable, at least in this first step.
Okay. I'll pause for a little bit.
I'm sorry, I didn't understand you, Andrea. Can you
I said
repeat,
I'll pause for a little bit and let somebody else ask some questions.
Okay.
Okay, so I would like to thank Mauricio for being here. And Mauricio, you have the floor. You can ask your questions and put your comments.
Thanks, Alfredo. Thanks, Renato, for the dissertation. So I want to start by saying that the engineering side of it, the technical angle you took, is really nice. It was also very cool for me to see there's so many undergrad theses you supervised, and then you folks delivered this big tool. I'm not sure if it's used in real life or not, but looks super, super cool. Cool. Now let me focus on the interesting part. So the first one is when I read your thesis, I saw the title, Metrics-Oriented Architectural Model, something like this. I got super excited because my PhD thesis back in the days was also on code metrics.
Yeah.
And then I was eagerly looking for a part in your thesis that you described what a metric is in this universe. Maybe similar question that Andrea has asked. Can you give me just one example of a metric? Because there's no one single example in the text.
Yes, and I can talk, I can give you examples and I can talk why they are not included in the project so far. So among the examples, as I said, first things first, I think that one of the biggest references that I have been discussing to use with Damian and Alfredo has been one that I put there a couple of times, which is Fenton's book, which it's a classic book about metrics. And it gave me a very interesting first idea of the definition of a metric as what you can measure, what you can do. So this background was important for me just to justify why I didn't put this yet there. Because I had an intuition of what metrics meant. And when I actually looked at the literature on metrics, I saw that I should be more careful on their definitions. And I didn't think so far I was prepared to make those definitions exactly. That's why, for me, the proposition of the SLR, because I think I need to dig deeper into what people are talking about metrics to be able to write myself and summarize myself what I have been thinking. That said, this is because I was going for a very careful methodological approach of how I wanted to write about the metrics. By experience, I have ideas that I could describe in my mind. I didn't put them on paper necessarily because I didn't think I had the rigor to describe them properly. But in examples, as I said, I think that number of data sources, it's something that could be very interesting to describe this complexity. Which components are or are not included in the size of these different components, because each of these boxes that I showed in the reference architecture can be a whole system with their whole mess inside them. So, it changes a lot if I have a data pipeline that has just a single step versus a data pipeline multi-layered that sometimes even have other modules inside it. So that's why I think when I look inside it, those metrics related to number of components, number of functions, can be a good proxy of the size of the problem each one of those boxes are. And then by understanding that, I think I can have a better idea of the connections between parts, because I know that in those systems, we have some of those different pieces. I showed that they tend to be very attached. For example, between the server and the training pipeline, you can have all this feature engineering part being shared between them, like a library, like a third service, whatever. So when we reach this point, I think it will be interesting to look for the code dependencies between those stuff to kind of see if a change somewhere can impact somewhere else. So I think these are some of the stuff that were in my mind, but as I said, I didn't think I have the rigor yet to properly describe them.
Thank you. So you give me an intuition of what metrics is. Now I'm going to expand. What is a metrics-oriented architectural model?
Yes, of course. So in my opinion, this idea of metrics-oriented architecture model, it's because first, I want to build those metrics mostly looking for the architecture of the system. And when I'm saying architecture, I'm going for the definition that architecture are mainly, I'll lend one of the definitions of architecture from, oh gosh, I forgot his name. Yeah, but this idea that architecture is or are some of the main decisions that we have on our system. So yes, I talked about some low-level code decisions, but I actually believe those will be less impactful than we looking between dependencies between major components. So I think this idea of doing some architectural recovery, understanding the big structure of the system will be interesting in that sense to make this model. Then why it's necessarily metrics oriented. So the idea is that first, why a model? The model is a simplification. So we are getting the system, transforming it into an intermediate representation. For example, a representation of the architecture, and over this representation, measure different aspects of this. So that's why it's metrics oriented, because the end result, the output, what it gives you as a developer are the metrics, the measurements that you can use. It is an architectural model because it depends on the architecture. And the name, as I said, is a little bit mouthful because I still hope to come up with a cooler name for the thing in the future, but I think that's where I'm going from, where I was coming from.
Let me try to see this in a more concrete way. So, okay,
yeah.
Here at Agile, we built a very large machine learning systems in general.
Yeah.
Very far from that, but we do. We're going to run your tool. We're going to get some metrics about our architecture. What do we do with those metrics? Does this help us improve in any way?
Yeah. So that's why my idea of having the third place to explore. And that's why I focused when I divide the third research question to tasks specifically. So I think the metrics are useful when we are trying to find refactoring spots, because, well, you know, usually those metrics and all the dependencies that we create to the process of collecting the metrics will give us, for example, points into your architecture that are very entangled. This is a great signal that you may have those problems that I said of the side effects, change something, impact somewhere else. So refactoring opportunities, your system is what it is, but I want to just pay some debt or understand, yes, and pay some debt, technical debt, in the sense of things that, decisions that you took and not necessarily were good decisions at a certain point, or where good decisions are no longer good decisions. But at least you have a better, more objective measurement that can guide you to find those spots and do it. And then related to the architectural proposals, most of what I thought is a problem that I myself had in the industry when I was working as principal machine learning engineer, is that someone asked me to put a new feature in one of those systems. And then I had multiple options of how to do it and multiple choices of what to do. Things like, okay, will I do which kind of those 3 types of server that I did? Should I do more complication on the data engineering part or the feature engineering, or in the end? So usually what I did is that I come up with multiple alternatives of architecture, and then I try to reason with my colleagues what would be the best trade-off. But, you know, it's always based on intuition, on discussion. I could not say to someone like, architecture A is actually more complex than architecture B on the data engineering part, because what is this because? You know, usually it's just because I look at the picture and it looks like it has more boxes. And this is very weak in my opinion. So in the ideal world, you know, it's 2 things that I would have liked to have when I was developing those systems.
Thank you. I'm going to talk a little bit about the execution of the next 2 years. That's okay. So when I read the methodology chapter, I noticed you're very ambitious, and you listed virtually every existing empirical software engineering method out there. Right? You want to do case studies, controlled experiments, surveys, and whatnot. However, the description of each one of those boxes, they were quite shallow, right? To say, I'm going to do a controlled experiment, but I don't see what experiment are you proposing, what variables are you controlling, or how the case study looks like, and etc. Which sort of shows to me that you still don't know, because maybe you're waiting for step 1 to be finalized, and etc. And to me, that's the main threat to your thesis, that you know very little about the whole experiment you're proposing. How much can this influence on your plan to finish this in 2 years?
Yeah, so the first thing is I need to finish in 2 years. This is not an option. So how much I will be able to do will need to fit on this space. And so when I come up with this plan, I think in my mind, this was a very optimistic measurement of time for most of these steps. And since I like the research career, I don't think necessarily that things that I don't execute will not be executed in the future. So as Andrea was saying earlier, I think I can finish a thesis with partial results or just part of the results that I did. And then in the future, in my research career, I intend to continue pursuing these things because truth be said, when I was discussing with Alfredo and Daniel some of the things that interest me related to the subject, my initial pieces, they are actually, I would say, even a simplification of what I actually would like to study, for example, which is the impact that the different roles of teams have over these different components, which is something that we took out completely because we said this would be undoable. We need to simplify even more. So, you know, I'm pretty open to even simplify and humble a little bit what I try to achieve. But I thought it was interesting to try to come up with this plan up to where it would be fully executed. The other thing for me is that, well, I really like to collaborate. As I said, I really like to work with other students, with other people, and I hope that certain pieces of this work, I can also work in partnership with other people. For example, Alfredo, we are discussing with Victor, which is a master student at IME that he's executing. He could help us to execute part of one of the controlled experiments. we also have other options of other study or other students. I have been supervised either on JADS or on IPT or whatever that, you know, so I think that I can do a pretty much orchestrated approach and try to share these part of those pieces that I cannot execute fully myself with other people to compose the overall research. I have to admit, you know, I like complex systems. Complex systems are big and made of multiple parts. So I'm not impressed I came up with a complex research plan.
Thanks. Thanks for the answer. So indeed, what I wrote in my notes here is that I think you're going to have to prioritize. I think it's humanly impossible to do everything you're promising in 2 years if put quality into place. It's just too much. I think you're going to have to pick which parts of it you're going to do in your thesis and then what you do in the remaining of your career for sure. You promised an ICSI paper, a TOZEN paper there. Those promise. You wrote about them. Those are not easy papers to do. I don't think you can do it
Not at all.
4 months or so. So I think you're going to have to pick your battles there.
Yeah. I would even say, I think this is much more of my intentions than necessarily promises, because I know, just for example, a journal paper could take a year to be reviewed. You know, those things will not finish within the time of my PhD. So even about writing those papers, I'm thinking mostly on doing things like, you know, if I achieve the result, write the paper, submit it, knowing that these are things that I can reuse in my thesis writing in the future. Even if they are not published yet, they're submitted, but I can also build my final thesis as an ensemble of those partial results.
Thank you. Maybe a final remark before I give it back to Alfredo. This is the first go, no go document that I read that has a full-blown how do you call it, acknowledgements section, how do you call it? So this, you know, you wrote as if you're getting a PhD. So this means you're promising your friends and family you're getting a PhD. There's no way back now because you wrote that section. Cool.
Yes, they know.
Yeah. Can I follow up a little bit? So I think Mauricio and I are not saying such different things, right? And what we're really asking about is, or highlighting, is what I would characterize as a different belief system, whether the study as a whole, everything that's promised can fit in 2 years, but also whether each of the individual components actually yields the results that you're hoping that there will be. And I think Mauricio's first few questions were much in line with what I was asking about, is like, what's a metric, or what's a metric architectural model? Because reading the 35 pages, we don't know what you actually see inside your head, right? Because you're like, oh yeah, it's going to work. I believe so. I mean, cyclomatic complexity and this and that. There's all these metrics. It's going to work. And we don't have that picture. And to just give you one example, it's like, well, cyclomatic complexity, well, that's not at the architectural level. So forget that one. Keep that one out, because Agile is not going to do anything with that, right? And so we didn't get a list of, here's 5 of the metrics that operate at the architecture level that I think are most promising, or that I think will apply because, right? There's no slide in that gives us any confidence that the foundational building block that you see, you're not giving us the opportunity to see the same thing, other than in some ways your enthusiasm and your words and your belief, but we're not seeing it because we don't see it applied to an example. We don't see it analyzed for its strengths and weaknesses. We don't see, you know, here's 5 metrics. Let's apply each one of those just to your system and let's see what it does, right? And what's the insight we get because it's a machine learning system. And in some ways, your answer worried me because your answer said, they're general metrics. They will operate by proxy. If I get like 3 or 4 and they all sort of say bad, bad, then, you know, it says the architecture is bad. Well, how do we know that the architecture is bad versus this is just inherent to a machine learning enabled system, right? Because I looked at your diagrams that are in there and go, wow, they're really connected. There's a lot of stuff going on. So most of the metrics I'm familiar with are like, go disconnect things. Well, maybe that is not so trivial. Maybe that is not so possible, right? And so I think I'm missing some initial belief or evidence that says, all right, I can see how step 1 yields an interesting set of metrics. With a little bit of step 2, if I apply it, I might get some insight. And I think that's for me the biggest worry and the biggest risk in embarking on this is, will even the foundational step work, right? And I think Mauricio is then pointing out that let's assume it works. Well, then you're actually going to do a case study and another case study. You're going to do a survey and you're going to do a controlled study and you're going to do this. And you said, well, I'm hoping to get some help with that. That is true, but the execution of these is the easiest part. The hardest part is the actual design of them and the analysis. And that will take a lot longer. And that's often something that is not easily outsourced to an undergrad. So sort of the high volume of things that you're proposing to do gives me pause, right? If your whole dissertation was recharacterized, perhaps, as do current architecture level metrics apply to machine learning enabled systems, that would be a much smaller part of this, essentially part 1 with a little bit of part 2. And that's something I could get behind, because now it would say there's a yes answer, there's a no answer, there's probably a medium in the middle somewhere sometimes answer, but you're going to get a lot of insights about applying these metrics onto architectures. And I think that to me would be a valuable contribution, and probably one that is worthy of a dissertation, and that still similarly sets you up hopefully for future, but it also leaves room for you to pivot and say, aha, I learned that none of these metrics are actually very good. I need to invent a couple of my own, right? Because that's not in your dissertation proposal whatsoever. And I worry that the specialized nature of these systems might actually require you to do something a little bit more tailored to them. So that's a long-winded way of saying the foundational step, I don't fully believe is going to yield you 20 metrics that are great. It might give you half that is somewhat decent. And then everything else leans on it, and everything else is a significant undertaking. Notwithstanding your enthusiasm, your hard work, any of those kinds of things, right? Nobody's doubting that. But we all have seen sometimes a dissertation where the foundational building block didn't work out in the way that it was supposed to work out. And in this case, that would have serious ramifications.
Yes, I mean, I think I should say that one of the key things, including of having this moment in our PhD program, is to receive this kind of feedback, because I think it's very important. You both presented a perspective that I think it's, I buy it because I understand that being more conservative and have a smaller scope is safer. I believe in lean principles. Let's make something more deliverable stepwise. And in fact, I have the same reading that indeed we could come to step one and don't know what it is. I discussed with them in a couple times, for example, that actually there is very few studies about metrics at all, about machine learning systems. So I think it's actually, there is some interesting contributions just in the understanding of the applicability, as you were saying, Andrea. And I think it's an interesting research direction. It's kind of like my project, it's like the happy path, right? So if true, we can go for a research like that, even, yes, it's a big research, as you said, and I completely agree. But career-wise, I can go with this research line, let's say. But maybe first I need to answer the if. If I don't know it, I can't count to go up to the end. I think you are offering me the else in this
Right.
question.
Right.
Any more comments? Mauricio, Andrea? Maybe Damian, it's your time now. You have to talk something. I want to hear your Italian accent. Do you still have it?
I still have the accent. Apparently, I figured out only recently that I can switch dynamic. Actually, it was Maurizio that told me at some point that I switch depending on the people that I have in front and around. But I don't do it on purpose. This is Maurizio's conclusion. No, anyway, to be more serious, I agree with your comments, Andre and Maurizio's remarks. Indeed, as a matter of fact, as you might remember, Renato, we've also tried together to try and narrow down the scope to try and make it a bit more focused towards a specific avenue, which is more concrete, for example, as Andre was remarking. And I still think that is a winning move. I like the fact that you've made an effort to make it so broad that you can indeed then eventually find your way, depending also on the resources that you will have in front of you. But perhaps we were a bit too loose in this respect. So maybe what we can do is, in fact, start from something simple, in the sense we go and look for architectural metrics, as Andre was saying. We style a catalog of these metrics, and we start from a systematic mapping of such metrics to understand, their consistency, the extent to which they are more compatible with that. I have, in fact, a comment on this. Your experience as an MLOps engineer might itself count as a self-ethnographical source of data for that exercise. Right? We've discussed this in the past. So you have already many of these answers. And I think when you were writing this plan, you know yourself that you have some of these understanding. The problem that I see, and maybe we were not too careful in explaining it also to Maurizio and Andre, is this should probably be factored into the research design, right? So the fact that you have this background, the fact that you have this experience, the fact that you could, in principle, distill this self-ethnographical experience that you have out of your past and compare it with that hypothetical catalog of metrics, that is there, and you need probably to start from that, factor it into your research design, make it a bit more explicit, and use it to your advantage, I guess, right?
Yes.
Does that make sense?
Yes, yes, and indeed we discussed about it. I think that in this some context that I told both Andrea and Mauricio that I would comment about it. We kind of pivoted to this idea of using metrics like 6 months ago.
Yeah, indeed.
Yes, because before that, we counted that we could use like access to systems of the company I use it to work that I unfortunately no longer have access as a way of, for example, doing some action research or even like document a series of experience reports related to that to build it. Even in this path of doing a self-ethnography, things could be really rich if we had access to that to actually showcase those things. But unfortunately, this door got closed recently. And then I had to come up with something that was non-dependent at all to have this. But I don't think that maybe even this idea that we're discussing now of going on the self-ethnographic route, maybe related to other projects like SPIRA, maybe going in other directions. I think it could be valuable. All the proposals we are making sound fun, like for me. So it's I'm pretty open to go towards to explore other paths.
Sorry. Well, in principle, you already have a number of methods, as Maurizio was also saying. You have a number of you have thought yourself for these methods, right? So the systematic literature review, just to pick one, can itself be an opportunity not only to find those metrics and tools and approaches and what have you, but it can also be an attempt to narrow down, to focus your study more and more, right? And the intent here is not for you to reinvent the wheel, right? So one question I had, for example, while you were explaining it, is you seem to rotate strongly around the interplay with the industry, which is fine in principle. There's absolutely nothing wrong. We have access to that, so I'm not worried about whether or not we will find these industries. Point is, do you really need it? I mean, why do you need the industrial assets? I mean, I've seen plenty of, actually most ICSI papers, if you want to go to ICSI or TOSA, most of them have nothing to do with industry or, don't have, let's put it that way, they don't have an explicit relation to industry.
Yeah.
Right? So if I play the devil's advocate, I would ask you at this point, so why do you want to go there? I mean, it's tougher. It involves the industrials. It involves even more data, maybe data that you cannot process to a certain extent. So it is, in fact, a risk.
Yes. The answer for me is just because I like experimental software engineering, and I think that the conclusions that we would reach would be richer if they were more based like that. So it's kind of like more researcher belief than anything else, and a desire of doing this kind of research. But I'm also very pragmatic, so I also believe that for finishing my PhD, in the goal of finishing my PhD, I might not necessarily need all those stuff. And truth be said, this would get rid of a very risky part of which is this dependency. What happened in my research previously, depending on the industry, is a great demonstration of some access can be taken away when you suddenly doesn't expect. But let's say career-wise, as a software engineer researcher in my life, I would love to do more of those kind of applied industry-related research. And I know these are the toughest to do just because people don't give us access to that. But I don't know. I'm brave.
Okay, can I follow up on that?
Please do.
Yeah. So another way of asking that very same question is, what knowledge do you want to contribute to the scientific literature with your research? Right? And I feel like part of your driver has been, I would love for this to have industrial impact or at least be relevant to industry. But an equally important question as a researcher has to be, what knowledge are you contributing that we don't know thus far? Right? And I don't hear you talk much about that, because I think you have that end goal of, I'm going to produce knowledge and I would like it to be applicable. But maybe actually not skipping the I'm going to produce knowledge, but asking yourself, what would be good examples of new knowledge that I could be contributing?
Yeah. I think I can associate this idea pretty much with my interest in studying machine learning engineering in general. Because like I said in the beginning of my proposal, I told you a little bit of the history of how the area come up to be. It's something very recent, and even something that I myself in my career could see appearing, showing up. And I really like this idea of people, what intelligent software engineering, whichever of those multiple names I put there, we are calling, because we are almost for everything that we did previously, we were asking ourselves, well, so is this still applicable? Does this still make sense? Which of those things or how different the use of AI in the middle of those systems are affecting this common knowledge, So I think that for me, contribution is much related to, can we put into scientific analysis more of those ideas? And as I said, when I talk with you, like, I have been a practitioner for a couple of years and I came for my PhD. So why did I came for my PhD? Because I like this idea that many of the knowledge I had and I acquired, for example, in the industry, I want to become scientific knowledge, because I know that we have many intuitions. I'd like to see that if my intuitions are true in a scientific way. And, I'm pretty certain that some things might be, I can come up to some negative results. Or, I mean, some contributions, maybe this doesn't work, or this is not actually functional, But that's why I think there is always this very practical aspect to what I'm thinking, because I think it even has to do with how I end up in the PhD, right? Trying to transform this knowledge back.
But I think the important part here is that you refer to this. And my question is asking you to be a bit more specific. What is this, right? So if I asked it differently and I said, give me 4 new bits of knowledge that ideally in your world would result from this research, what would they be?
Yeah. For me,
concretely, right? One-liners.
Yeah. For me, it's much related to this. I would summarize in decision making, just to correlate with the research questions I put in there. I talked a lot about this idea of things to improve, things to maintain those systems. And when I was there in that position, making improvements, make those things, there was always this decision-making aspect that I had in my mind that I think that's great value, So I said in the beginning of my thesis, most of the projects fail. Very often they fail because complexity goes out of control. I have techniques to avoid this. And I think this is very related to this decision-making process of I should choose path A rather than path B, or I should avoid doing certain stuff in certain parts of it. And if I could make this more scientific knowledge, I think it would be pretty cool because, again, I have the intuition of many of those decisions. I am not certain. And that's why I think metrics could be interesting, because they could make more objective some of those judgments that help you to make those decisions. But it's something that I was a little bit, I had a step behind of promising this, because I think it's also very ambitious to say that I have the right decision making. I don't know if I have the right decision making for those stuff. So that's what motivates all of those third things. I don't know if the same decision make I would have is the decision make other people would have. But could I give us the kind of thing I see? So to see if people come up to the same conclusions, to the same processes.
Right. But don't set your sights like way up here, right? I think you're still not as concrete as I would like you to be. So I'm going to give you some examples that may help, right? I would like to see out of this dissertation that out of the 32, I'm making up the number, architectural metrics, only 2 apply to machine learning enabled systems. Or I would like to see out of the 64 architectural metrics that I found, only 4 can be operationalized for machine learning enabled systems. Or to operationalize architectural metrics for machine learning enabled systems, we need to integrate metrics that actually examine model complexity. Because if we have metrics for model complexity, it turns out that they relate to the code complexity, right? Or 4 different shortcomings of architectural metrics when applied to machine learning systems are A, B, C, and D. Or something that gets closer to what you want, a typical decision that we make when we architect machine learning enabled systems is X. By using 3 metrics, this one and that one and that one can guide making that decision in a better way, right? So you see how concrete I'm trying to make those, and they're not even fantastic, right? Please don't take those as these are the answers, but those are specific nuggets, specific bullets of new knowledge that you could generate with this kind of work, right? Yeah. That would lead up eventually to what you want to do, but you got to sort of come back and say, what are the intermediate steps? What are the intermediate bits of knowledge that I can add in papers along the way?
Yeah. And it is, in a sense, in a greater granularity. I understand more what you are, proposing here, Andrea. And as I said, I think maybe this is also lack of experience of my part.
Don't worry. Don't say that. Yes. This is us guiding you, right? This is the purpose.
Yes, of course. Yes. But I am saying this in this sense because the perspective that you were presenting is not necessarily how I thought about presenting my results. But I think it's pretty cool. I actually didn't thought about it. And that's why I'm saying that I think that's cool to listen from people more experienced than me.
Can I say something, Renato? So it's been 3 years since I left academia, so I'm going to beg the pardon of my academic colleagues here. But if I compare your presentation and your excitement about the topic and the text, it feels to me that you have a pretty clear idea on how you can improve the lives of machine learning engineers. And instead of just sparkling a little bit of science to try and show that your idea makes sense, you put the entire bowl. So, for example, you have good ideas of metrics, but then you're proposing a 1-year systematic literature review because maybe you need to be a little bit more complete. And then you're proposing 3 or 4 case studies or so to prove that, time after time, those ideas might make sense or not. So I feel like, and the beauty of software engineering is that engineering mixes up with science, right? And science doesn't have to be the main dish to me. To be really honest, I feel like if you have a great idea on how to make the lives of these people better, just implement it. And then, of course, use science to show that it makes sense, but not the other way around. You try to make science the main dish of your thesis, and it should not be the main dish. Your contribution should be the main dish.
And maybe, and thank you for saying that, because I'm not necessarily disagreeing, because what you're pointing at is there's a different variant of this dissertation, which is Renato has 3 metrics that he thinks are good. So took part 1, right? Study the 3 metrics in the context of the example system you already have in hand. There is another chapter, and then maybe apply it to one other case study, and you're done, right? Here's 3 metrics that would help in this and this way. And here's the strengths of the metrics, here are the limitations of the metrics. Because you also can invent metrics, or you can say these 3 I think are good. There's no need to go around and saying these 50. Let me see which ones are good. If you have a couple in mind, you could also run with them, right? So there's different ways of cutting and shaping this, but I think they're all about being much more concrete in your choices and not going, let me do this scientifically fully right. Let me do this scientifically fully right. Let me do this scientifically fully right. And in the meantime, I have a 20-year career. No, you got a PhD and you got 2 years. So what is to you the most important thing to select that you want to demonstrate as a small piece of knowledge, right? So one of the things we always say at UC Irvine is, your PhD is like this tiny little pebble somewhere, right? And there's a big rock sand, and there's an ocean, and there's all sorts of stuff, but you're just doing one tiny little pebble. Which is the pebble that you're focusing on?
Yeah. No, it's pretty fair. I mean, as I told you, I like the idea of devoting a little bit more the context for a more experimental first approach, which is my reading of what you were saying, so come up more from practice back to theory than necessarily from theory to practice. I think for me is also a pretty cool venue to execute it, those stuff,
So I really appreciate all the comments, and I really love it to see you showing a path. I really love it. I really like it. Maybe it was my fault to be kind of more academic, more let's base on the state of the art, and to kind of annoying Renato to do this SLR and everything. But so I assume it. Sorry about it, kind of. Do you have additional comments? So now we have the kind of the closed session, and I'd like to invite Damien also, even if he does not have the right to vote, to participate. Renato, could you send us to a private room? Teleport us?
I am not entirely sure. Let me try to do something different. I can open Google Meet room for you, and I just send you the link. I think it's a little bit easier than try to switch things here at Zoom that I don't know if it's gonna work, right?
Does it work for everyone? Mauricio, Andrea, Daniel?
Yeah, fine for me.
So
Yeah, we just got to come back here afterwards, right?
Yes.
Okay.
The same link that you used originally will bring you back, so you don't need to worry with that. And I actually had, yes, yeah, I actually had here, because I had a open thing here for, I'll send you the key.
okay, see you soon there. Let's go to the Google Meet.
Yeah.
Okay.
I'll be around.
Okay, perfect. Oh, Renato?
Oh.
You have to open the room before, because you cannot enter.
Wait. 1 second. It worked, right? Yeah. Ooh, now let's wait.
Hello. So Renato, we discussed it, and unfortunately Mauricio cannot come again because his son has some issues, but nothing serious. So we discussed it a lot, and we decided that we are going to pass you. However, we want to have a checkpoint in about 3 months because we really need to see some kind of preliminary results showing that you are capable of doing it. So we are saying, okay, we trust you, you can do it, but you need to show to us in about 3 months what you did it to show that you are in the right path.
Okay.
Yeah. So sort of a combination of here's some initial little results on metrics and the systems, and here's the concrete outcomes that I'm hoping to achieve in a scoped down version of my dissertation.
Let's go for it.
You can do it.
So,
That we're all convinced. We're all convinced, but you can't do the whole thing. We're also all convinced about that. Yep.
So you have the chance to show us that you can do it in 3 months. It's not an official thing, but Andre and Mauricio are giving some time to you, so to show that they appreciate your work and you can do it. But show to us.
Okay. Well, thank you again, guys, for the participation and for the comments. I think everything will be very valuable for me to execute these next steps. And yeah, I am excited to keep studying about it because the subject has been very cool so far. So let's do it.
Yep. Agreed. Congratulations.
Thank you.
Congrats.
Thank you.
And let's have a closer chat next week, me and you, Rena.
Yeah, let's do it.
Cool.
Okay.
Okay.
Thanks a lot.
See you later.
Okay.
Thank you, guys.
Thank you again.
See you. Ciao.
Bye.
Thanks a lot.
Bye.
Ciao, Alf. Be good.
Renato, quer bater papo?
Peraí. Eu vou parar a transmissão.
Você percebeu um pouco